Okay. So I guess today I'll give you an assignment with around 5 to 6 questions and about half a week to complete it. Right. So let's start today's meet. Is the screen visible? Clearly visible. You guys should remember that while I'm sharing my screen, I cannot see your text. So it would be better if you just speak out. Otherwise, I have to switch in and out. Okay. So yeah, the last two topics of Python are basically exception handling and classes. Right. Classes is the important topic, and exception handling is a very small topic. Right. So let's say we write a program. Alright, let's yesterday we learned file handling. Like we could use that. So let's say open test .txt and write it in W mode. We run this. So a file is created. Okay, now file is created. Now let's write something in it. Something Python. So I guess that is that's good for starters. Yeah. So let's say we open this file in read mode. Like now, if I say something like file dot write, right, and let's say I write something file, let's say line 2. Right, when I run this will give us an error called unsupported operation. Right, so this is what is called an error. Right, so let's say I delete this file and then I try reading it, it would still give us an error saying no such file or directory. Okay. So what exception handling does is it prevents the program from stopping when an exception or an error occurs. Now it should be used in it should be used rarely when there's no other way to prevent the error. Let's say here, right here, you want to open a file, but for some reason the file was corrupted or removed or something, and you do not know that, and your program just want to access that file, and it would basically generate an error. But we can prevent that error by using something called exception handling. So the basic syntax of exception handling is a try block. The try block which has code that may have error. Alright, then the except block, which is the code that is run when an error occurs. Right, and then there's this else statement, which basically says if try has no error, execute this. And then finally the finally keyword, which is basically executed irrespective of error. So this is the syntax of exception handling in Python. So we can again run this file and it will give us an error. So let's try to clear that error. Let's say try, and we put that into an intended block. Then we say except, and then we say print error has occurred. Right, so this will work fine. Let's run this. As you can see, it does, the error has occurred is printed here. So what happens is it moves to the try block. If there's an error in the try block, the entire thing is not executed, right? And then it moves to the exception block, and it prints. It does whatever the exception block tells it to do. So what we can do right here is, if it is not open, we can just create a file test.txt, and then we put in W mode, and we can print here file created, and we could say here file open. So when we run this the first time, the file is created, and then we run it the second time, the file is open. All right. And then if, let's say, what we wanted to do is finally complete, and then use the finally statement, and then we use the file dot closed. So finally, the statement under finally is executed irrespective of if there's an error or not. So let's say I remove this and I print file closed, and I do this file dot close, not close, file dot close. Right, it says file was created. Now we can run this. So you can see the except block is executed and the file is created, then the file is closed. Then if we run it again, the file is opened and then the file is closed. So the finally statement is executed irrespective of whatever you do. Like if there's an error, it would still be executed. If there is no error, it would still be executed. So let's say you know the type of error that may occur. So let's say again file equals to open test.txt comma 3, and let's delete this file right here, and let's comment this open. Till here. When we run this, you can see the error is generated. The name of the error is file not found error. Right. So let's copy this. Let's remove this, and we do this. So if you know the type of exception that may occur, you can basically limit the exception block to only that kind of exception. Let's say now this will only run when the file not found error. It will only be executed when the error type is file not found error. And then you can say something like except again, and you can print some other error. Okay. Alright, so what happens now is, let's say there is no file. Alright, we try to read it, but it gives out an error. So we go to the except method, And the accept method, the first accept method is limited to the file not found error. That is, it will only handle when the error is file not found error. Alright, and then it will execute this block. Now let's say there's a different kind of error which occurs, then this will not be executed because it only catches the file not found error. Then this will be executed because it catches all types of error. If there is nothing in front of except keyword, then it catches all types of errors. And if there's something, some kind of error, the names of the errors are basically fixed. There is this name not file not found error, name not name error, and a few errors. I do not remember all of them, but yeah, this will only catch the file not found error, and this statement, this one will catch all the errors. So let's say we first of all do this, and you see the file created statement is executed from the file not found exception. Now let's say file dot right. This will now work. So when we run this, this part will be executed. Right. We do this. So you see the file is open, then it cannot write something, so it prints. It goes to this block and it prints the exception right here. And then it goes to finally and it prints this. Now let's say we can also use the else method here. So let's say print file dot read, right? And if the file is empty right now, let's put something in. Let's put test string in. Save, remove that. We run this again. As you can see, it goes to the try block. It prints the statement. It does what the try block tells it to do. Since there is no error, it skips this except, and goes to else. Now let's say if there's an error, it would not go to else. What the else statement means is if there are no errors, then go to the else statement. And it would go to the final statement irrespective of what you do. Right? So this is basically the syntax we're talking about. Try the code. The try block has the code that may have an error. The except block has the code that is run when there is an error, and the else statement is run if there are no errors in the try state in the try block, and finally is executed irrespective of any error. Right, so that's it for exception handling. Now we'll move on to the classes part, but before that, if anyone has any doubt, they can ask me. I'll take 30 seconds of time, then we'll move on. Okay. Ashutosh running it out. Okay, so we can move on. So classes is the core concept behind object-oriented programming. Alright, what object-oriented programming says is everything is an object. Right? An object is basically, let's say, an object is basically, let's say, an instance of a class. Alright, you can compare them to the real world things like anything that's lying in front of you, what you may be holding, or what you may be sitting on is an object. Alright, so object-oriented programming works on the same principle that everything is an object, and every object has every object that is of the same type has the same properties. Alright, so let's say you are sitting on a chair. Alright, so the chair is an object, and the object has the properties 4 legs, alright, which every chair will have. Right. And I guess um, what other object can we think of? Yeah, let's think of a bottle object. All right. So the bottle object has the attributes, its size, and its capacity, and its material. All right. And the bottle object has the method of storing stuff. All right. All the bottles will have different shapes, different quantities, and all, but their method would be almost the same. All right. So this is what the concept object-oriented programming basically means. And what classes are the classes are the blueprint of the object. All right. Let's say, as I said, chair. Right. Chair has a fixed blueprint. Right. The uh, measurements may vary, the size may vary, but the blueprint remains the same. So the syntax basically is to make a class, you use the class keyword, then the name of the class. Now the name of the class has to be in something called, I guess it's called ladder case or something. But what this means is the first letter has to be capital. Let's say all right, let it test class. So every word, sorry, the first letter of every word has to be capital. So let's say test class. So here C is the first letter here, and test is the first letter. So it has to be uppercase. Okay. Now the same colon, and then an enter, and then the four space gap or the indentment. Okay. So this is what a class looks like. This is the basic blueprint of a class. Now, a class may have its attributes and its methods. Right. Now, attributes are basically the variables it has. Right. Like in case of a chair, its length, its uh, its color, and stuff are its attribute. Now, the methods it can have, the methods it has is basically the functions that are inside of a class. All right. So this is a difference. This is a function, but let's say we use os dot get cwd. Now this is a method because it is a method. It is a function inside a class. It is a method now, right? So the inbuilt functions are functions, and the class functions are methods. Right? This is not a very important difference, but it can be asked somewhere. All right. So let's first create an attribute. All right. Test class. What attribute can it has? Let's say it has the value attribute called 0. Let's say 10. And let's say it has a method called increment, right? Which what it does is returns value plus 1. Right? Now this would give us an error, but I'll show you what this error is. So this is the basic blueprint. Alright. Now this is not a complete blueprint. This would give us an error, but this is what the blueprint or a class would look like. Now what you have to do, what you have to create an object of the class to access the methods or the variables. Alright, so let's say P is equals to test class and then this. Right, so let's say print p dot value. Now this will not work. Let's see. This works somehow, but yeah. When we do the function part will not. So we create an object P from the blueprint or class test class. Right? Now P has all of these things stored inside it. Right? So you can execute it in the event method. And this part will give us an error. Let's say self value self dot value. Okay, self is so as I was talking, the self part, right? Earlier you may have used things like let's say string with space dot split, and let's print the output. And let's comment this, right? You may have did this thing earlier, and what this does is this is the string object and this is the string method, the split method, right? So when this is executed inside Python, it is converted into basically split and then the string with spaces object, space object, right? So inside a class, this is what the signature of this split functions actually looks like. All right. So every method inside inside a class should have this self thing with it. Right. This actually tells the class that it is implementing something that it always it is getting something that is his own, his the class's own. All right. So self dot value actually means that it is executing its own class. All right. So let's say if I say value is equals to 1. All right. Now we do this. This gives us. We'll move this, and I do this. I forgot the comment print, and you can see I changed the value here, and still it gave us the 11 output. This is because for the class, this value, uh, uh, this value variable, and this value variable are completely different. This value variable is its own. It is the value here. As but here the value belongs to the we can say this value belongs to the method, and this value belongs to the class. All right. So so the basic signature has to be the function and then the self part, because whatever you do when you do this, right, increment.test, in the background it is converted into increment and t inside it, right, itself inside it. So you have to pass that parameter right here. Okay, so this is what a class looks like. Now if you have used an object-oriented program, object-oriented language before, like I guess Java, then you must have seen the constructor. Right. So in Java, constructor is basically something that has the same name as the class, and it does not have a return value. Alright. So in Python class, so Python also has constructors, but they are initiated in a different way. And this method right here with the exact name, this should have the exact name, is a constructor method. Right. So let's make some changes so I can demonstrate. Let's create a doc class because originally so yeah, we first of all do this. Let's give it a name and a breed. Right. Let's make a move variable which takes movement else this, and let's say position is equal to 0 right now. What it does is self dot position is equals to position self dot position plus movement, and return I return an F string which says I am at position self dot position right. And let's give it a name. Self dot name is equals to name, and self dot breed is equals to breed. It should work. I think position and position right. So I guess this should work, right? Yeah, we can try this and see if it works. So we'll make a dog class. Now we create a dog and then we pass in the arguments asked here, the name. All right, so let's call the dog and let's call he's a German Shepherd. We run this. Yeah, it has to be BRWT. All right. The German Shepherd. So here there are no others. Let's call it self dot name. And let's print dog dot move. Let's move it 10 positions. Right. Now I will have to give it a name. Let's call it is a German Shepherd, right? We can just call him Shepherd for now. As you can see right here, right, first of all we created a dog object, and this is created using this is creating using the class name and then the signature now earlier when I created the my class it did not have the init method, so we did not need to pass uh, any arguments. But now that I have created an init class or a constructor basically, which takes a name and the breed. I will have to pass them, right? Then I can, now that this has been created, now I can basically uh, use all of its methods and now I can use all of its methods and etc. I can also do print dog dot position, right? So when I call the move method, this this method is executed, and when I call the position method, the position attribute, we get this position attribute which has been changed from right here, which has been changed right here. Here, this is what a class looks like. Now let's say, let's, what are we missing? I guess, yeah, we're missing inheritance, right? So let's start inheritance. What inheritance is basically one class taking something, some methods and attributes from any other class, right? So let's say we fit a dog class, so we could create an animal class, right? And we will have to change this, so we can do this. Now what this means is that whatever is inside this parenthesis is what is inherited by this class, right? So let's say define an init which takes the species, species, I guess that's the spelling, and then it's itself dot species equals to species. So let's remove this for now because this will be overwritten otherwise. And let's say self dot species. Right, so let's say dog 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 dog. Right, I guess this should work. Yeah. Now as you can see, I specified species in the above class, but it can be freely used in the class below. Right, I used it in a way. I used it right here. This is what inheritance looks like. Right. What you basically do is you take the above attributes and the above methods and copy them to the below given class, the inheriting class. Alright. Now what you can do is, let's say, now when I do this, let's see, when I run this, this gives us an error. Why this happens? Because now that I've created a method with the same name as the parent class. This is the parent class and this is the child class, just like what actual inheritance looks like. So this is the parent class and this is the child class. And when you create a method with the same name as the class above, as the parent class, it is overwritten, right? What this means is now the dog class will not use this init method, but it will use this init method or this constructor, right? Now what we can do here is, let's say we still want the species, right? We still want to put in the species, so we use the super method, the super function, and the method we want to take in. Right, we take in the init method, and we by default give it the species dog. Right, now this should work. Third, and the breed is German. Yeah, I guess this should work fine. Yeah, as you can see now that I did this, alright. Now it calls when I create the object, calls this function, does whatever inside it, and when it encounters super dot init, what it means is this part inside the function is copied here with this argument passed here. Right. So what this basically means that this is here with the species part being dog. Alright. So that's what basically classes are, and they're used very frequently for major for almost all the projects, because let's say you create a game, right? Now you have to create a player and the actual board, the actual configurations. So let's say you do not use object-oriented programming. Then first of all, you will have to basically the the character's attribute. If the character attribute has any changes, you will have to change the methods and attributes in a lot of places. Like instead of that, if you used the object-oriented programming paradigm, you would have to only make changes in the characters class. Alright, let's say there are 5 characters, all of them have different attributes. Alright, so if you use object-oriented programming, you could just say a parent a class character which takes a name and has the basic functionality, and then the different 5 classes for the 5 characters. Alright, for the 5 factors which have their special attributes that the others do not have. Now let's say there's any change that needs to be made to all of the characters. Just, okay. So let's say there's a change that has to be made to all of the characters. So you basically have to go to the parent class and make the change, and it would be all done. But let's say you do not use object-oriented programming and you create 5 different character, let's say modules, right? And if there is any change in the in all of the characters, let's say common attribute, you'll have to change them in all the places. On the other hand, with object-oriented programming, you will have to only change it in the character parent class, right? That has all the common functionalities of all the characters available. So this is why the object-oriented programming paradigm is used, and you should uh, try experimenting with them. And let's see if I'm missing something. Uh, okay, so yeah. They classes also have some special functions. Like this is a special function. Right. I'll show you another special function which I remember. It is the str function. Fine str takes the self attribute. And always remember the self attribute is very important. All right. So let's say ring, not ring. Return this is a, let's call it a f string, self dot species with the name who is a self dot read named, let's say, self dot name. Good. Now you cannot call this function directly, right? But you can call it using the print statement. So if I say print dog, print the dog object, it goes here and it basically does this. All right. So the print method in any the print method, when you use the print method for, let's say, printing a string, what it basically does is it goes to the uh, str method of the string class and basically uh, returns what is told to be returned. Right. So as you can see, this is a dog, which is the species, who is this is the breed name, and this is the name. Right. This is basically what object-oriented programming is, and this now completes our entire core Python thing. And I guess now we can have an off day tomorrow. So yeah, so tomorrow you guys will have an off day. I'll upload an assignment today, and you have around 3 days. Let's say 3 days to complete it. Right. If anyone else needs more time, like they have some exams or anything, they can tell me now so I can extend the deadline right now. Right. Stop sharing. And Kanika ma'am, Adeshma ma'am can be excused because of her personal issues. Right. So Adeshma, that is no problem. And yeah, what I was coming back to what I was talking about. If anyone has any doubt, first of all, in what I taught you today, like object-oriented programming basically takes some practice to get used to. First of all, so don't expect to like master all of it, and take it slowly and focus on using classes more over just writing your code randomly inside the IDE. Okay? First of all, that, and then coming back to the assignment part, if anyone hasn't had the exams or something, they can tell me now so I can extend the deadline, I guess 2 or 3 more days. Was everyone comfortable with the deadline of, let's say, Tuesday? Okay, Mr. Archula. And there was one more thing. Yeah. Now, the last question is, um, how comfortable are you guys with the Python language now as a whole? Like, let's say, can you solve some kind of problem statements in them right now? Come on, everyone, be quick. I need answers. Can you help me with the pattern problem? Yeah, star pattern problem. I can help you with that. So So you can contact me personally with your problem and I will solve it. Alright. So coming back to the question, how comfortable are you guys with solving complex, if not complex, easy to intermediate problem statements, like using loops, while statements, and things like that. Problem statements are not very complex. Like you would not have to use classes in them, but you will have to develop the logic and understand the syntax, use the various Pythonic ways provided, things like that. So how comfortable are you guys? Surprisingly, no one is even comfortable replying, so I don't know. So okay, so that's the problem. Telegram, if someone has any problem, I think they'll have to ask me directly now because supposedly they are not comfortable here. So yeah, I guess that's it, and that's it for today's class. And you can leave now. Kanika, please take the attendance before anyone leaves. And thank you, Kanika.
I have taken, sir. Thank you, everyone.